And I started the stream.
Yay, stream. It's a thing.
How was TwitchCon?
It was fabulous. And I kept laughing because one of the things that they have up on signs everywhere is bleed purple. And probably three-quarters of the people there had their hair dyed purple. And as someone who has hair that is dyed in part purple, which predated my involvement in TwitchCon, I know that when your hair is dyed purple, the shower looks like you bleed purple. And so I'm trying to figure out if that came from someone who dyes their hair saying bleed purple because they've seen the inside of their shower, or if someone was just like, that's the TwitchCon colors. Either way, I'm thinking that like at least three-quarters of the showers in the Long Beach area got bled purple upon.
Oh. Uh, Good. Well, I'm glad.
It was excellent.
I should have gone. I
You
should
should
have
have.
gone. I
You should
didn't. I
have.
didn't even realize that it was happening. To be honest, you were like,
And
"I'm at TwitchCon." I'm like, "That's a thing."
yes,
So,
it's a fabulous
but
thing
I've already bought my ticket for. Well, I'm going down to Patricon, which is happening in a
for
week.
Patreon.
Yeah, and then I've already bought my
Excellent.
ticket for VidCon for next year, so I'll be attending
Excellent.
that. So.
So I want the lowdown on Patreon.
Mm-hmm.
That's going to be so cool and so artistic. The thing about TwitchCon is so many of the people who follow streamers are like young enough that biologically I could be their mother.
Mm-hmm.
And I kept going up to booths, and you could see the people at the booth was doing the "Where's her kid?" It's just like, no, I'm the one trying to talk to
But
you.
you got to do a panel with Scott Manley, right?
I
Yeah.
did, and he's
Isn't
fabulous.
he? He's so much fun. Yeah.
And I got to hang out with Dr. Erin Mack, who's also fabulous. She's an astrophysicist and was part of the LIGO team, and now does a bunch of consulting work down around the Los Angeles area. Yeah, and the Inertia TV team and all of them. So yeah.
Fantastic. I can say hi to a bunch of people. Hey, Adam Synergy, Arnold B, Astro B, Menkalo, Barrett Klenkar, Brian Stab, Chappers97, Christopher Beck, Colin Jones, Galaxia, Guido Bibra, Harry M, Henrik Bo Anderson, Hugo Burnham, John Suffield, John Victor, Johnny Zed, Just Looking, Quadlibet, Lakshadip, the Celestial Guy, Nancy Graziano, Noel Ruppenthal, Ocean McIntyre, S. Wahlberg, Susan Hunter, Susie Murph, Tak Tang, Thomas Traniker, Tori Gadwa, William Bacon, and Zapvan Zapvan. Hey, everybody. And especially hey to you folks who are in Europe, who I know have a hard time being able to participate with the weekly space hangout. So I'm glad you're here and able to join us for this live episode of Astronomy Cast. I'm
Yes,
sorry we
welcome.
made you choose.
But you can come to our Sunday CosmoQuest office hours on Twitch, which are held specifically timed to be Europe friendly.
That's cool. Patrons. Okay, so if you have no idea what it is that you have wandered into, you're about to watch a live episode of Astronomy Cast. We're going to do episode 463, Pareidolia and the Moon. Is that like a band? Is that an adventure
It should be
story?
a band. It
Yeah.
really should be a band.
And then we're going to stick around and answer your questions about space and astronomy.
I'm going to tweet that.
What, that Pareidolia and the Moon should be a... Larry Beckham, your color's looking better, Fraser, not so radioactive. Just you wait. And now, welcome to Canadian winter. So I will just keep getting pastier and pastier like the rest of all of the panelists. And then as soon as I can, I'm outside all the time, as much as I can. Yeah, you can still see it's pretty, still have quite the tan. But yeah. So let's get cracking. I'm ready.
Okay.
I've got my intro ready. I've got.
And the way you said that now has me thinking of cephalopods.
Which?
You said kraken instead of cracking.
I didn't say release the Kraken. I just said let's get Kraken. Kraken. Oh. I'm ready to press record. Are you ready to press
Okay,
record?
sorry. I am clearly being a scattered person today. I
Fine.
am ready to press record. I have pressed record. It is recording. Hello, Chad.
Hey, Chad. Astronomy Cast, episode 463, Pareidolia and the Moon. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today. With me is Dr. Pamela, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific and the Director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. How was TwitchCon?
It was fabulous. And as I was saying in the pre-show, they have signs up everywhere that say bleed purple. And I'm thinking that because so many people had their hair dyed purple, which is like amazing brand strategy, commitment, all the things. Um, People actually like bled purple all over the showers. It was, but beyond that, so that's like my personal amusement. There were so many amazing people, so many amazing technologists there. I watched a woman, Noob Cat is her channel, who did live coding of an IRC bot and a Twitch overlay. And it's like, I just want to like pair program with you forever. And so yeah, it was awesome. All the coders, all of the gaming, all of the art, all of the things that I'm kind of passionate about, all of them were there and dyed purple.
Right on. I'm going to take just this quick intro just to remind everybody about the excellent weekly space hangout that we do with our co-hosts, the three doctors, Morgan Renberg, Kimberly Cartier, and Paul M. Sutter. And this week's guest was amazing, Dr. John Charles. He's the chief scientist at NASA's Human Research Program. So he is the person who makes sure that astronauts are healthy at NASA. As someone so it was an amazing interview. I got a chance to ask all of the questions that I always have, and it was great. So if you're not already listening to the Weekly Space Hangout, highly recommend. Go ahead, you can subscribe to it wherever podcasts are found. And if you're listening to it, or if you listen to both for Astronomy Cast and for the Weekly Space Hangout, if you could give us a rating and a review on iTunes, that would mean the world to us and help other people find the work that we do. All right.
And if you're interested in discovering other podcasters, both our feed, the Weekly Space Hangout, and many others are aggregated at 365 Days of Astronomy. So yeah, get all of us and enjoy all the content. And I'm going to give a shout out to Fraser, whose Guide to Space was once again nominated for Parsec. So kudos to you, Fraser.
Here's to the fourth parsec in a row. The Man in the Moon, the pyramids on Mars, every cloud ever. Humans have a tendency to pattern match when they're looking around the universe. It's called pareidolia. What causes this behavior, and how can we use this to debunk some hilarious conspiracy theories? All right, Pamela, will you put this into the docket? You chose the moon, but man, I would say a good 10% of my job is to let people know that thing that they think they see is not what they think they see, and to sort of debunk stories that are going around. There's a bunch of UK newspapers that do a lot of this. Anyway, so what is this idea of pareidolia?
So basically, human beings, like many other mammals, once upon a time had a problem with being eaten by tigers. And it turns out that if our brain is capable of seeing the tiger in the grass that is not actually in the grass, that false positive is way better than missing the tiger in the grass that wants you for dinner. So the human brain got really good at finding faces, at finding all sorts of different patterns in things where those things just don't exist. And this has led to a Glee episode that featured Jesus and a grilled cheese. This has
Right.
led to a blog post by our friend Phil Plate, who found Stalin on his shower curtain in Steam. This has led to so many different things. And it also has led to so many different stories and myths. The constellations at a certain level are kind of pareidolia, but not quite. But that man in the moon, that face that those of us living in North America see in the moon, that's totally pareidolia. And there are so many stories from so many different cultures that see different things in the moon's face that we picked that as a starting point. But I don't think we're necessarily going to end while still on the moon.
Right, right. And so I think that's the part that's kind of useful for human evolution, is this idea that, as you said, that we're looking at trees, we're looking at shrubs, we're looking, and our brain is going, is that a saber-toothed tiger? Is that a saber-toothed tiger? And you can see why it's a very important sort of evolutionary trait for us to have gained, and there's not really a big downside to it. Like, oh nope, turns out it wasn't a saber-toothed tiger, but it was, chances were that it could have been, and if it was, then I would have spotted it and I would have not gotten eaten. But as always, we live in this modern society with all kinds of things going on, and sometimes it sort of messes with our brain. So let's talk about some of the things that people see in the moon, and that's where you wanted to start, and it's definitely where we're not going to end. But so what are the examples of things that people see in the moon?
Well, the main one, as I said, is the old man in the moon, where the lava flow, the mare, is perceived to be two large eyes and a mouth making a face out of the moon. But that isn't really the most prominent thing that people see. Rabbit is one of the things that comes up over and over and over again, where people look at the moon and they see in the lava flows these two ears, a little face, a round body, and a tail that is kind of pointing towards that really big apparent crater down towards the south side of the moon. And so, bunny, hare, rabbit, whatever you want to call the bouncing two eared critter that um, exists pretty much on every continent except for Antarctica. Uh, Bunnies are where it's at, pretty much wherever you are in the world.
I'm finding these images, and I'm showing them on uh, to the people that are chatting. But the thing that's hilarious is that people have actually seen multiple different kinds of bunnies,
Yes.
and so I've actually got an image, and I'm sorry to the folks who are the podcast listeners. Maybe we can put this into the show notes. I'll but there's an image that shows a bunch of different bunnies. So it's not just like there's one. There's multiple different ways that you can sort of perceive the craters, and if you really squint hard enough, you can actually see the various versions of the rabbits. It's pretty funny.
And beyond the rabbit, just to go more reptilian or I guess amphibian, in Chinese culture, they see a toad instead. And the toad is one of those things that once you see the toad, you can never unsee the toad because it is essentially this happy little toad hanging out on the western edge of the moon with its little hands out in front of its little head. And it has some other rocks or something in front of it. And I swear, now that I've seen the Chinese toad in the moon, I will never unsee it. And there are folks that actually see a second toad as well off to the eastern side that is stretched out mid jump with its arms in front of it and its legs streaming out behind it. So there's two toads happily frolicking across the face of the moon.
And keep in mind that it's all about perspective, right? The folks from the southern hemisphere see the moon upside down compared to us, or perhaps we in the northern hemisphere see the moon upside down compared to you. Everything's relative. I'm not going to take a stand on which is the right way up in the universe, but and so I've got to assume that all of those faces and animals and things that we see, when you flip everything upside down, you see completely different shapes and structures.
And this is where, as you look at the things found by different cultures, rabbits, pretty much you keep rotating the moon and those ears are just there like there's a bunny here. going to see a bunny. But other features, definitely, you don't find the man in the moon in Southern Hemisphere cultures. This is where you instead start getting things like the crab in the moon. And the crab in the moon, it is one of the ones that comes from South Sea Islanders, where they see one of the big blobs of lava as a single large crabby claw. They see the biggest thing of lava as the back of the shell, and you can connect the smaller pieces of dark mare to get the different segments of the claw reaching out, and it's fabulous, and just shows that there's something in the human mind that demands that we find these patterns. As children, we all found things in the clouds, and it appears that across the millennia, everyone has found things in the moon.
Yeah. So that's the moon. Now I think where this probably hits home to a lot of people has been some of the conspiracy theories about other objects that are being seen on the moon, and people have seen like cities,
Yeah.
right?
So this actually starts to go back to Percival Lowell
Right, of
using
course.
his telescope to look at Mars and claiming that he was making out man-made canals. And over the years, we've had people take photographic images of the moon, of Mars, and digital images taken by spacecraft. And in those early low resolution images, they took mountains and claimed they were pyramids. And I think the structure that we're most familiar with is there is a feature on Mars in the Cydonia region that they actually did an in search of episode when I was a little kid with Leonard Nimoy narrating away about this face on the moon. And
The face on
it's,
Mars.
yes, face on Mars. And when you look at the early low resolution images, the way the shadows are cast, the way the mountain is structured, it looks creepily like someone went all carvy on Mars and engraved a human face on this mountain range. But as we've gotten progressively better and better resolution images, it's become more and more clear that no, this is just like normal, everyday mountainy feature that just happens to have an unfortunate resemblance when seen at low res with the sun at just the right angle to looking like a human face. But really, it looks no more like a face than the old man in the mountain in New Hampshire looked like a face. You can see it if you squint, but no one carved that.
Right. And so the part that's kind of hilarious or sad is that the conspiracy theorists took this very low resolution image with this really harsh lighting and constructed an entire fantasy civilization on Mars and like we have been dealing with the after effect of this, the conspiracy theories, the people writing to us to talk about this for decades still. And I mean, like now that we've got these wonderful and these wonderful pictures, and I was able to show some to the live audience, images from NASA's Mars Reconnaissance Orbiter that takes images at less than a meter's resolution. It is clearly a rock. It's clearly a mountain, and there's kind of no question to this, and yet it sort of generates this thing. And then there's the pyramids on Mars as well. Same situation.
And as we've started studying craters, and we see this on a fairly regular basis with CosmoQuest, where we have volunteers going through and mapping out craters on the moon, Mars, Mercury, Vesta. People keep stumbling across snowmen in crater chains, where you get three craters ordered by size in just the right way to look like Charlie Brown's snowman. We find nearly infinite faces, smiley faces, emoticons. And it's not just the craters, it's also, again, lava flows seen zoomed in, where people have found there's an elephant out there. There's an elephant formed out of lava.
Right. And I think in recent times, the part that sort of it's kicked it up to the next level is you've got these images coming back from NASA's Curiosity rover that is taking all of these really high resolution images of the landscape around it on the surface of Mars. It's getting images of rocks, and it's seeing a vast array of different rocks, and it's moving so much and taking new pictures and moving and taking new pictures. And then NASA, to its credit, takes all this data and just dumps it onto the internet, where anyone who wants to can look through the raw images being taken from all these different cameras on NASA's Curiosity rover. And of course, people's pattern matching, right? I wouldn't be surprised if a person actually sees a saber-toothed tiger on the surface of Mars. But so far, they've seen sticks and Bigfoot and
There's a woman. There's a woman. Dr. Matthew Francis wrote a great little article about this image that I don't know how to describe it other than she looks like she's about to go drown herself in the ocean. It's kind of it really looks like a haunted house woman traveling across the surface of Mars, and it's just this shadow, and the way the shadow falls across the land, it's a creepy little woman. And he says, zoom in and you'll stop seeing it. No, I zoom in and I keep seeing creepy little woman. But part of the reason I wanted to do this is because I know I see faces and stuff all the time. And it's not just faces. I sometimes see just pattern matching. I'll catch them being out the corner of my eye. I once screamed very loudly because I reached down to pet a gray kitty and it turned out to be an opossum. Not the same creature. And our brains just fill in missing data. And this is the problem that we're dealing with is our brains are essentially integrating over what isn't there, looking for details that aren't actually resolved. This is how humans do basic pattern matching. And this is one of the things that makes us so different from computers. If you give the early, I think they've gotten better, but if you give the early computer vision algorithms a smiley face, two dots, and a parenthesis, they're like, I don't know what this is. It's two dots and a parenthesis. A face has a nose, cheekbones, structure, eyeballs, lips have features. The human brain is capable of going, no, no, no. I can fill in the details that aren't actually there. I can assume emotions that parentheses don't have. And so where we run into problems with pareidolia is the human brain filling in data that isn't there. And also the universe is essentially not 1,000 monkeys banging on typewriters, but a few million volcanoes spewing lava. And you spew enough lava and you're going to get an elephant on Mars.
Right. Yeah. So I guess that sort of leads into the risks and the dangers and like on the one hand, obviously, when a person sends me a picture and says, I found a space civilization on Mars, and you can clearly see that all it is that they took their picture, they blew it up a bunch of times in Photoshop, and there's all these artifacts that are causing this grid in their picture, I can just kind of ignore it. But where does this become more of a problem, especially for scientists in terms of their bias?
Well, our bias as scientists has largely become, we won't believe any of it because we know the human brain is fallible, which means that there are things that we found on Mars that look kind of like fossilized bacteria mats. And no one wants to say they're fossilized bacteria mats because that's pattern matching, and we haven't gone up and like touched it with a probe. And so we have reached the point of we know we're fallible. And I know I'm mispronouncing that word.
Fallible could also be a way to
Yeah,
say it.
right. And so it's hit the point where it's going to take extraordinary evidence to make even fairly ordinary claims, simply because we've learned brains lie. And this is luckily where we're out there using mass spectroscopy. We're out there digging into things. We're out there touching things with robots. And we have the ability to eventually get the extraordinary data to make ordinary claims. Where it's going to get interesting is we keep finding things in radio signal that turns out to be like, that's a pulsar, that's a maser, that's just like something weird but normal and non-repeating. And we keep trying to find those radio signals that are indicative of civilization. We keep trying to find so many things. We desperately want to find life out there. And it's going to be one of these things where when we do find it for the first time, no one is going to believe it for a long time, except for the poor person trying to go, I actually found it. No, 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 this is real. Part of me, it's like the Tabby star. If it is a megastructure, we're going to have to go visit it before anyone admits that.
Right, right. Like, even if they're able to remove every single alternative answer for what Tabby Star is, although it looks like they've kind of figured it out now, but even if they haven't, then the claim is so outrageous,
Yeah,
that this sort of falls into that Carl Sagan trope, right? That extraordinary claims require extraordinary evidence. And so, yeah, if indeed you think that you have seen a dinosaur bone poking out of the surface of Mars, just looking at the shape of it, knowing that human beings are fallible, then you know that we would need to send some kind of follow-up, fossil grinding tool to be able to get to the bottom of that question.
and the thing to always remember is that so many abstract artists can stand there and randomly splatter paint onto a board, and people will find in those splatters what they want to see. And sometimes it's just their subconscious wanting to see something. Ink blots, we find shapes in ink blots. Our human mind was designed to find shapes. We're extraordinarily good at it. And we're also extraordinarily bad at perceiving reality. So these two things fight against us. But embrace it. Embrace the fact that there is an elephant shape out of lava on Mars. Embrace the fact that there are smiley faces on world after world, and hearts and snowmen. Embrace it, delight in it, and then science well, we all know what the book said.
I showcase to the people that are watching. Again, this is a very graphics heavy episode of
We're
Astronomy Cast.
sorry.
Yeah, but I wrote Hello Astronomy Cast in galaxies because I can. Because there
Yeah.
are, thanks to the folks at Galaxy Zoo, they found galaxies that match every single letter of the alphabet. In fact, multiple versions of those letters of the alphabet. You can go do a search for Galaxy Zoo alphabet, and you can actually find a generator that'll let you build any text that you want written out of entire galaxies. Just think, you know,
As you do. As you do.
hundreds of billions of stars, and their only purpose is so I can write words, which I think is awesome. And I guess so. One of the things, of course, that you're working with Cosmic Quest is having human beings look at photographs in ways that robots are really bad at. And you get that good and the bad. So have you had some really interesting sort of pareidolia events where people have been like, I think I see something?
So I got an email that when I read it, I couldn't help myself. I was sitting in the Admirals Club at LAX and I laughed in a way that caused everyone around me to just look. Someone found, this is a kid-friendly show, someone found a phallus in a crater chain, and it was undeniable what it was that she found in this crater chain. And we will be doing a blog post about this sometime next week. I'm trying to get one of our science team members to explain the science behind how this phallus was formed.
Somebody did, was it Phil? Somebody, or was it you? Somebody did a presentation, I think at Dragon Con, with this sort of filthy
That was Phil.
That was Phil.
Yeah.
Yeah. It was not rated for the whole family, but it was pretty hilarious. The kinds of objects that are out there in space as well.
Yes.
Well, on that note, we're going to wrap this up. Thanks, Pamela.
My pleasure. Okay. And now we save. Welcome to the boring part of the episode.
What did I say this was?
I don't know.
What did you say it was? This was?
It was a thing.
It's 463.
Thank you.
But don't upload.
I'm going to pause Dropbox.
Yeah, that's right. Adam Synergy's mentioning in the chat there are rude wheel tracks on Mars.
Yes. Scott Maxwell, did not think through the ramifications of one particular 3-point turn. He did.
I'm gonna find that. Rude Mars rover tracks. Oh, just to remind everybody who is, there it is. Oh, that's so funny. Anyway, for those of you who are watching the live show, just want to remind you, if you can't always show up for the live show and you still want to hear the banter, the full show, we have the full feed, so you can always go and listen to that. All right, here, I'm going to put this up. Hope people can see what there you go. Mars tracks rover just driving around on Mars. So. And
I have to admit, this show was entirely inspired by the email I got of the phallus pic of
oh, really?
Yes.
Well, the inspiration for episodes of Astronomy Cast come from the most unusual places.
It's much better than hurricanes and death and destruction.
Really? I know that's what you love. So wait, go ahead. Now we're going to take your questions about space and astronomy. So go ahead. If you've got a question, just go ahead, drop it into either the chat in YouTube or go ahead and put it into the chat in Slack, and we will gather them up and answer them. How do you, Miss Gravitational Waves Curmudgeon, how do you feel about the colliding neutron star discovery?
So I'm going to point out that discovery was only possible because Europe fairly recently spent money and built an array. And if they had just all gotten their shit together at the same time originally, we might have got here a whole lot faster. So I am happy that it was found. I am a curmudgeon for all of those years that we funded it and it didn't have the ability to find anything. Anyone else would have been defunded.
Now, I had heard, I think Scott was talking about that in his presentation of it, that the Virgo actually had one spot that was its blind spot in the sky. And so it didn't make the detection, which is how they knew where to look for it, because it was in the one spot that it couldn't see. It should have detected it, but it didn't, and therefore they knew where it was. But I haven't confirmed that. Scott Manley was saying that in his video, but I haven't followed that up.
Okay.
The exo Arjun saying, where do they think the exoroid came from? I don't,
So
exoroid?
there's an asteroid that's currently passing through the inner solar system that has an orbit that requires it to be a rock that was thrown at us by an alien solar system. There is an ongoing debate on Twitter about what we should call it. I'm going with exo rock because exoroid sounds like something you need a cream to
But
treat.
so does an asteroid. You can get over that. Exoroid is great. That has my vote.
Exo asteroid at least, because
Exoplanet.
exoroid simply means
Yeah.
outer thing,
Exoplan.
or actually it means
Ex.
outer like.
Exonet. Yeah. Okay. All right. Exoasteroid.
Yeah. So I'm fine with exo asteroid because that means outer star like. Okay, fine.
Yeah.
We can go with that. Um, but yeah, so a rock from another solar system was flung at us, and that's all we know. And that's all we know.
Yeah.
So I can't really speculate beyond that, other than it's really cool to be able to say that alien solar systems are throwing rocks at us.
And we're throwing our rocks at them.
It's true.
Yeah. Now I recall, I wrote an article about it. I didn't know the name. That's all, the exoroid name. So, yeah.
Yeah.
Astro B wants us to get serious. So
have you not seen our show?
I know. I don't understand. But they say that gravitational waves are only detected on the narrow frequency band. What is the possible bandwidth?
I don't know. I'd have to go get myself really up to speed on that.
Right, but if I sort of understand the question, that there are the sensitivity of the current gravitational wave observatories are sort of, they're only able to measure events where the waves that come through are of a certain frequency. And yeah, I don't know what that frequency is, but it is close colliding neutron stars, and it is black holes that are, say, in the tens of times the mass of the sun coming together. Anything that has a lower mass than that, like a stellar mass black hole that's maybe got a couple of times more than the mass of the sun, those collide too quickly, and they don't give off enough of a gravitational wave that the LIGO system can detect it. And the supermassive black holes, they actually, even though they let off enormous gravitational waves, they come together so slowly
it's too long a frequency.
That the frequency of those gravitational waves are just too long. And so in order to be able to detect, to essentially go outside of this sweet spot that they're at right now, they're going to need to be able to make detectors that can find both. And probably the only way to be able to do that is to send some kind of space-based observatory that's going to be able to do it. And that's LISA, which is that next big sort of space observatory. And that's going to be this constellation of 3 spacecraft. They're all going to fly at 1.5 million kilometers apart in this formation, and they're going to be shooting lasers in between the 3 of them, and in the same way that LIGO does, but the distance is going to be enormous. And then again, they're going to be able to measure any difference in the length between these spacecraft, and so determine what was going on. And that will provide a whole next level of that frequency that they're going to be able to detect. So we're going to have to wait. Yeah, there's probably some more sensitivity that we can do from ground-based observatories, but we're almost at the sort of edges of that, and now it's going to be space-based from here out. And there's the next one beyond LISA is called the Big Bang Explorer, I think, and it will be a constellation of 12 LISAs in this huge constellation. And if it's able to pull it off, it should be able to actually detect the oscillations, the gravitational wave oscillations from shortly after the Big Bang, before the cosmic microwave background, which is, of course, our, the furthest that we can see in the various spectrums, the electromagnetic spectrum. So it's kind of it's an amazing thing. There you go. Astro B, serious. Brooke Mulgado wants to know, what is the speed of gravitational waves? Light speed?
Yes.
And now we know for sure.
It's and we've been trying to get at this for a long time. It's always been in the noise. Now it appears we know for sure.
Yeah. And but hold on. The thing that was amazing was that the folks at LIGO detected this incoming gravitational wave from the merging neutron stars. They did it for 100 seconds, and then at exactly 100 seconds after they began receiving their signal, NASA's Fermi telescope detected a gamma ray burst in the chunk of the sky where it came from. And so that's the part that's amazing, is that the gravitational waves arrived early because those neutron stars hadn't smashed into each other yet. They were spiraling inward, and then when they actually collided, then you got that blast of gamma radiation, and the two synchronized perfectly. And people were asking me, like, oh, if it's the same speed, how come you got the signals arriving at two different times?
They're generated at two different times.
Yeah.
And what was super cool about this is the gamma ray folks have it like baked into their software to notify everyone, oh my God, gamma ray burst, everyone put your telescope at it. Like, people literally get text messages when gamma ray bursts are detected. And so their network's firing off the alerts while the gravity people are like, we had an alert. Let's sort this alert. And so it was out of sync to get the two teams realizing that they were actually working in sync.
Yeah, on the same object.
Yeah. It was awesome.
Yeah.
I really hope someone writes a book about this discovery, because it involved 3,500 astronomers, 15% of the world's professional community, in this one discovery.
Jorge Schrauen asks, if they're both as fast, is light speed still a good name? That's not the name that physicists use anymore, right? I mean, they still use the term light speed.
C. We use the letter
right,
C.
But isn't
it's
it
the letter
speed
C
of causality?
I've never heard that phrase before.
Okay.
It's light speed, but it's the letter C. We just use the letter C.
Quadlibet says that LIGO can give us a 2-minute warning in case Betelgeuse blows up. Well, not.
I don't know. I don't think it would detect that.
Maybe. No, well, it wouldn't. Well, maybe if it's close enough. But the problem with something like Betelgeuse is you're not going to necessarily get the gravitational wave unless it's in some way lopsided.
Yeah.
Which is one of the possibilities for how these supernovae can go off, is it can be lopsided and explode out like Mount St. Helens, kind of collapse on one side first, and then you would get some kind of gravitational wave. Christopher Beck asks, are gravitational waves Doppler shifted? Yes.
I can't think of why they wouldn't be.
Yeah, they are. Yeah.
Okay.
Yeah, I had this a bunch of times as well. It's funny, every time I post a new video, I get a million questions from people, and it's sort of, I then have to like find every answer to all the pieces and be able to respond. So I've been, neck
So there's
deep
a
in
Star
this.
Trek question. There's a question involving Star Trek. Space TV says, I have a random question about dwarf planets that has been on my mind for a while. When they decide to use the term dwarf, did they also consider using terms like Earth-class planets or Saturn-class planets? Sort of. So what we have is terrestrial worlds, and the terra part is the Latin root for Earth. So instead of saying Earth-like, we say terrestrial, and we get all fancy with our Latin. Then we also have ice giants, which is a unbiased way of saying it's similar to Uranus or Neptune without like naming it after one of those two. And then we have gas giants, which are the Saturn and Jupiter-like worlds. And dwarves are just small and sad.
Yeah, I mean, I think that classifying planets means something different for a star-faring civilization that has the ability to travel in warp speed and discover new planets and try to classify them based on their requirements. And right now, all we've really got is mass and orbit. and whether or not it's in the region that can have liquid water.
Yeah.
That's about
Well,
as
we have differentiated and undifferentiated for the rocky things. Um, yeah, it's I hope we someday as a civilization, probably well after you and I are no longer around, get to the point where like M class planet is a thing, but we're not near there yet.
Ben Kalo asks, are neutron star collisions shorter duration events than supernovae?
I don't know how you figure the start and end point of a supernova. So, a supernova light curve, the amount of time it takes for that inner cloud to cool off can be a couple of weeks.
Mm-hmm.
And the neutron star merger is kind of instantaneous.
Yeah, it was about 4 days, and then there was nothing you could really see anymore with that one.
Yeah, and that's the afterglow. So the question is, what do you use as the start and end point of the collision, and what do you use as the start and end point of the supernova? So, it depends on how you decide. It
Yeah.
depends on how you decide to define it.
Well, it's a
The
different
core collapse
mechanism.
part, right? So the supernova is a core collapse issue of like the entire star goes whoop in on itself
Yeah.
and then bounces out, and it's that bounce out thermonuclear explosion cool off period and expanding cloud which expands forever. What parts do you use as start and end? And then the neutron star collision also is a kind of nova. And so yeah, I don't know how you want to define it.
Yeah, I mean the speed of the supernova, the core collapse as those layers are falling inward, it's a significant fraction of the speed of light. It's
Yeah.
going like I forget what it is. It's 30%, 70% of the speed of light. It's going really fast as these layers are infalling into it. And I know that with the binary neutron star collision, at the last moments, the two stars were going hundreds of times a second around each other. They were going a third the speed of light as they were whipping around each other and starting to kind of dismantle each other as they came together. But
And this is where it gets at, do you only count the period during which they're actually merging and that shock wave is given off? Because then you're looking at just seconds, but do you count the entire time when they're in close together? And yeah, it's a story, not a moment.
yeah. Christopher Beck asks, what is the distance between stars in a globular cluster? I'm trying to imagine what the night sky would look like from a planet within the cluster.
I love that you're so determined to Americanize your pronunciation of that. Uh,
Globular cluster. It's fine. Have I not told you that I've looked it up and both pronunciations are correct?
I know I'm
And yet
married to a
everybody makes fun of
Canadian.
me, and I'm just so
I
sensitive
don't.
about it.
Okay.
I'm just a delicate flower.
um, so I believe that it's typically under a light year.
Yeah.
They're compact. Binaries form randomly as things get too close to each other. You actually have stars that like re-merge together and form blue stragglers. It's crazy land out there in those globular clusters.
But, the amount of radiation that gets to Saturn, say, is like 5% of the amount of radiation that we get here on Earth. And so if you go further and further out, the brightness of that 1 light year away star from you
Oh,
is going
yeah,
to be like
it's
Venus, right? Like it's going to be a very bright star, but it's not going to be it's not going to be making turning night into day.
right. It's the sky is going to look more like a bad Christmas decoration scene. And so there will be more than 1,000 points of light glowing a little more brightly than you might wish if you were trying to get to sleep, but you're still going to have a day night cycle. And the part that makes it crazy awesome is the fact that these stars do, because they're in such a high density region, do actually tend to like grab a hold of each other gravitationally. Binaries form, they fall apart. You have three body interactions. You have stars that merge together. So luckily, we have yet to discover any planets in globular clusters. The stars in globular clusters are extremely poor in high atomic number elements. So you don't have the stuff you need to form planets. And so there's a chance that there's no planets out in globular clusters to be tortured by too many lights in the sky.
Yeah. But so it would be an amazing. Last night was amazing. The night sky that we had here, just very dark, very, not a lot of like mist in the air, so it was just really clear. Everything was just so bright, and yet those stars, the brightness of those stars, is nothing compared to what it would be if you were in a globular cluster. So that would just be like, I think, we would feel just like, wow, that's amazing. I hope. But at the same time, you would be able to sleep at night and you wouldn't go crazy. You know, just be
Yeah,
like it'd be neat. Be
it
a
would be
thing that
neat.
most people would be bored of, just
It would be
like
like way
everything.
too many Betelgeuse or Eta
Yeah,
Corinas in the
yeah.
sky,
Sirius is in the sky.
but lots of red stars like Betelgeuse. Lots of red stars.
Srihari Ayapila asks, can an asteroid collision with the moon, say, cause detectable gravitational waves? So could we get them closer?
No, not really.
Not
So,
detectable. But
so
they're
what's
happening.
they're happening, and what's interesting is the kinds of gravitational detectors that they're using are actually sensitive to things like the UPS guy driving down the street. And so they have, well, I mean, that's probably an
It's not the gravity.
overstatement.
It's not the gravity of the UPS driver, right?
So they have actually been able to measure the change in gravitational pull of a dry mountain versus a wet mountain at the gravitational center in Seattle. So
Wow.
when they have heavy rain, they actually have to take that into consideration when they're doing their gravity research. So we have amazing abilities to detect the gravitational force. Uh, but in terms of energy being dissipated via gravity versus a change in force due to large mass coming by, we we aren't to the point where we can detect those waves from just like, hey, I'm going to whack the moon. Not
Yeah.
there.
And that really shows you how weak and how faint those gravitational waves really are. The amount that they are stretching you is utterly insignificant. And
Gravity really is the weakest force.
you're the
It,
weakest force. Goodbye.
we don't want it to go goodbye. Then the oceans would not stay
Right.
attached to the
Right.
planet,
Right.
and we'd have space whales, but in a very unfortunate way.
Yes, space whales. Yeah. Right. And so, I mean, anytime you move, as you walk down the street, you're generating gravitational waves. Congratulations. And I guess you're converting some of your mass into gravitational waves. So it's a way to lose weight.
I'm not sure. I'd
Well, the
need to
black
look
holes,
into
when
the.
they collide, lose some of their mass
Yeah.
into gravitational waves, right? The energy for the gravitational waves has to come from somewhere. So you give it up from your mass. Any more questions for us? What are you watching?
Huh?
What are you watching?
What do you mean? What am I
What
watching? Like
television
on.
shows do you watch right now?
I have to admit, I've been watching Star Trek Discovery.
Me too.
Um, I kind of adore the disco shirts. I want a disco shirt. um, so that's fabulous. I have been ordered by multiple people to watch Rick and Morty, so that is on my to-do list. I know, I suck. And beyond that, I'm gonna probably like binge watch the Stranger Things 2 season as soon as I'm done with tomorrow is International Observe the Moon Night. So everyone go outside, look at the moon, tweet about it, Instagram about it, hashtag observe the moon. One world, one moon. We can all see it. All of us go out, look at it.
I would one thing that I would watch. I mean, of course, watch Rick and Morty first. The fact that you put Star Trek in front of Rick and Morty is an insult to science fiction everywhere. But man, I can't even get over this. No, you should watch Mindhunter on Netflix.
Okay.
Yeah, and it's just terrific.
I am writing this
Yeah, I
down.
really enjoyed it. I think it's one of my favorite Netflix shows now. It's really good.
What's the premise? I'm trying to.
The premise is it's about the
I
FBI
tend to watch
agents.
things
Sure.
in.
It's about the FBI agents back in the 1970s who set up the FBI's behavioral psychology division.
Yeah, I was watching that. That is really good.
Yeah, and it's not like some kind of horrific serial killer thing, although there is some violence and stuff in it. But it's just this really great story, like it's a real life story told of the people trying to set up this, and I really enjoyed it.
And I have to admit, I am totally addicted to Criminal Minds. So my CBS All Access Pass is getting me all sorts of weird, happy goodness.
Well, so this is real Criminal Minds.
Yes.
This is where it came from. All right, well, it's the end of the hour, so I think it's time for us to wrap things up. Thanks as always to our fans for watching the show live, and for those of you who have signed on to the full feed, hello.
Welcome. I'm waving. You can't see that.
Of course, you want to join the WSH crew and they're the people who contribute this chat down at the bottom. Go to wshcrew.space and you can join that community. Thanks, Pamela, as always, for bringing the brains.
Patreon. Plug the Patreon.
Sure. Go to patreon.com/astronomycast and join our Patreon campaign. Even like $1 a month allows us to have Chad, for example, as our editor, to be able to have Susie's work. We really appreciate your folks' support, and it means the world to us and allows us to continue doing what we do and not have to pay out of pocket to be able to do it. So, and we've of course been here for more than 10 seasons. So, and now podcasting is cool. Finally.
It is.
So,
and bow ties.
Bow ties are not cool.
They are if they're on Matt Smith, who's Doctor Who.
Oh, okay. All right. All right. Well, thanks everyone, and we'll see you all. Won't be next week. That's right, because I'm going to be traveling next week, so we're going to be Wednesday.
No, we're Wednesday. Yeah.
We're Wednesday at noon, I think. Yeah. All right. We'll figure it out. We'll see you later.